Hello everyone, welcome to my channel. I'm Thomas and I do educational videos on this channel, mostly of the kind of the variety of the esoteric and obscure, but also I was just looking at a different article written on the same topic. They call them the uncommitted investigators. These are generally like amateur scientists who, are not being paid by some large university or research organization. They don't compete for grants. They don't have anyone else's agendas to comply with. They are out for the truth, and as a result, they have done all their work and they never got paid. Nobody ever knew they were doing it, just a small group. And many of these people are crackpots, but many of them are, you know, onto something and put together a huge treasure trove of great information and great research on things that very few people know about. And so I've tried to discern the crackpots from the true uncommitted investigators and to bring to light some of the great theories that I've come across over the course of my life. Today is a video number 194 that we're doing on Dewey Larson and his reciprocal system of theory. And Larson lived in the 20th century, died in 1990, spent about 60 years developing his reciprocal system of theory. The basic idea is that we live in a universe of motion. The universe is not made out of matter. It's not made out of energy. It is made out of motion. Matter and energy are merely two different kinds of motion. Motion is the relationship between space and time. Example, speed. The car is moving 15 miles per hour. 15 miles of space in 1 hour of time. That is a relationship between space and time. That is speed, a motion. Most people would grant me that. Speed is a kind of motion, and speed is a relationship between space and time. But not only speed, but really all other quantities that are, of the mechanical or physical in science are motions, such as acceleration, force, pressure, like I said, matter, energy, viscosity, fluidity, compressibility. These are all forms of motion, and as a result are all relationships between space and time. And so Larson has an entirely different notation for his system. Everything, every quantity can be reduced to space-time terms. And so you can kind of create your equations based on only time and space. And you don't have to have your MKS system or anything like that. It's just time and space. And that makes it very easy to make sure if your equation is correct and so on. Now, it's a little bit more complicated than that because, first of all, space and time both have their coordinate aspects. We know that space has a coordinate aspect, X, Y, Z coordinates. Space is 3 or more dimensions. Like I said, X, Y, Z coordinates, Euclidean geometry, or beyond that, possibly. But what we don't generally recognize is that time also has its coordinate aspect. So there are 3 or more dimensions of time as well. And then space and time also both have their clock aspects. We generally recognize the clock aspect of time. Time is always getting later and later and later. It's progressing, it's flowing. Um, and this is what Larson calls a scalar motion. This is a motion that has a magnitude, but it has no particular direction. Or you could just say it has every direction. And you would envision this by using a balloon and a magic marker, putting a bunch of dots on the balloon and blowing up the balloon. This is an outward scalar motion. The dots are all moving away from each other, but in no particular direction. And if you sucked in the balloon, then the dots would all be moving toward each other. That is an inward scalar motion. And we recognize that time has that quality of the clock, that it's always getting later and later and later, but in no particular direction. But we generally don't recognize that space also has that quality, that space is always getting farther and farther and farther apart. Even though that was demonstrated by the Hubble telescope over almost 100 years ago, where they showed that they might have used some kind of sleight of hand to show it, but they purported to show that all of the galaxies are moving away from each other. The distant galaxies are all moving away from each other. That is the progression of space. Space and time also have what is called their discrete units. Space and time do not come continuous. They come in chunks, very small chunks, but chunks nonetheless. There is a minimum unit of time, and there's a minimum unit of space. And exactly 1 unit of space in 1 unit of time is the speed of light. So that really sets up 3 boundaries for this universe of Larson's. Sets up 3 boundaries based on units, 1 unit. So the 1 unit of space in 1 unit of time is the speed of light. The speed of light is what Larson calls unit speed. And so this unit speed is a boundary between 2 separate universes, or sectors of a universe, which Larson calls the material sector and the cosmic sector. The material sector is the sector that we know about, and that our scientists have measured and observed. And this is the universe where where things are moving slower than the speed of light. But we also have what Larson calls the cosmic universe, and this is where things are moving faster than the speed of light. And the speed of light is actually the minimum speed of that universe. That is the universe that Einstein didn't know anything about, nor do most of the other mainstream scientists out there. And then within each one of those 2 sectors, there's another boundary that's called the unit. Within the material sector, you have the unit space boundary, and within the cosmic sector, you have the unit time boundary. So once you go inside of 1 unit of space, you don't have space anymore, because space only comes in units. So you have this world of time, which Larson calls the time region. And then in the other sector, in the cosmic sector, you have this region where you can go less than the 1 unit of time. And that is what Larson calls the space region. Now, in the material sector, you basically have coordinate space and clock time. This is what we're familiar with. 3 dimensions of space or more, and then progressing time. But in the cosmic sector, you have 3 dimensions of time and progressing space. So even though we know nothing about this cosmic sector, we can extrapolate what we do know about the material sector onto the cosmic sector by simply inverting the roles of space and time and putting the role of space into the role of time over here. So that makes the reciprocal system very powerful, because it basically doubles our knowledge about things just by simple extrapolation and using that reciprocal relationship. Okay, now there's obviously a bazillion other things to talk about the reciprocal system, but we are looking at Larson's 1979 book that is called Nothing But Motion, which is primarily on atomic physics. And we are in chapter 13, which is called Physical Constants. And Larson is kind of trying to readdress the situation of constants, going through some of the constants and showing how many of them in legacy science are fudge factors. They're just numbers that they use in order to make the equations balance out, or make them correct in terms of the numerical value, such as the gravitational constant. And he is putting everything in like the gravitational equation into units of time and space, and then see how they balance out. So we're going to take over kind of in the middle here. We're at the very end of the chapter, I believe, or toward the end of the chapter. Maybe we'll finish it today, but so we will start up where he's talking about the gravitational constant, and he's already raked it over the coals a little bit, but we'll start up right here. The dimensions that are mistakenly assigned to this term, this ratio of 1 over n squared, belong to a term whose existence has not been recognized because it has unit value and therefore does not enter into the numerical calculation. In order to put the as-if gravitational interaction on the same basis as a real interaction, we have to express it in terms of the action of a force on a resistance, not as the action of a mass on a resistance. And since the dimensions of the mass term cancel, so that the gravitational mass enters the equation only as a dimensionless number, the force of gravitation has to be expressed in actual force terms. That is T over S squared. That is the time-space representation of force. The correct dimensional form of the equation is then the quantity S to the third power over T to the third power, gravitation, times T to the third power over S to the third power, which is mass, times T over S to the second power, which is force, equals T over S to the second power. Turning now to the numerical magnitudes, we note that while the dimensions of the M1 term cancel out, the magnitudes do not. Every unit of mass is both a unit of S to the third power over T to the third power, gravity, and a unit of T to the third power over S to the third power, mass, each in its own proper context. Since the units are independent, the effective magnitude of the as-if action of m units of gravitation against m1 units of inertial resistance is m times m1. However, expressing both of the mass terms in conventional units introduces a numerical error, as only the inertial mass term is counterbalanced by a conventional mass magnitude on the other side of the equation. To compensate for this error, a corresponding inverse factor must be introduced into the gravitational constant. There is no error if the gravitational mass is expressed in natural units, as the value 1 does not require any counterbalancing term. The relation between the natural and conventional units therefore determines the magnitude of the necessary correction factor. 1 gram is 6.02486 times 10 to the 23 units of inertial mass, 1 mole. T to the third power over S to the third power, mass. The reciprocal of this number is 1.65979 times 10 to the minus 24th. But only 1/6 of the total number of mass units is effective in the gravitational interaction, because this as-if interaction takes place in only one dimension, and in only one of the two directions in this dimension. The total number of gravitational units, s to the third power over t to the third power, corresponding to an effective mass of 1 gram, is therefore 9.95 times 10 to the minus 24th, which he got by multiplying by 6. Expressing this mass as 1 unit overstates the numerical value, and a correction of this magnitude must therefore be included as a component of the gravitational constant. A small additional correction is required because of the effect of the secondary mass. Gravitation and inertia are inversely related relative to the primary mass. That is, the primary mass is P over P plus S, units of gravitational mass, and also P over P plus S, units of inertial mass, where P and S are the primary and secondary masses, respectively. The product of a unit of gravitational mass and a unit of inertial mass is therefore 1 over 1 plus S, the quantity squared, units of primary mass. Where the result is expressed in terms of inertial mass, another 1 plus S factor is introduced. The total effect of the secondary mass is then the introduction of a factor of 1.019299. Applying this factor to the value 9.95874 times 10 to the minus 24th, we obtain 1.015093 times 10 to the minus 23rd. Replacing the 1 over s squared distance term by a t over s squared force term has the effect of introducing a time dimension, which must be expressed in natural units to avoid creating a numerical unbalance. The numerical value of the natural unit of time is 1.520655 times 10 to the minus 16. Offsets in part the errors in the mass term. The net correction to be made is 1.015093 times 10 to the minus 23rd divided by the natural unit of time, and amounts to 6.67537 times 10 to the minus 8, which you may know that it is the gravitational constant in the CGS system of units. Looking now at the question of conversion to a different system of units, the issue that initiated the restudy of the situation, we find that a change from CGS to MKS units in the conventional form of the equation, preceding equation, results in a change of 10 to the minus 6th in the mass term, 10 to the minus 4th in the distance term, and 10 to the minus 5th in the force term. A change of 10 to the minus 3rd in the gravitational constant is then required for a balance. In the theoretical equation 13.3, the net effect of a change in the system of units is confined to the relation of the natural and conventional units of mass. As can be seen from the explanation that has been given, the gravitational constant is proportional to the ratio of these units. Changing the conventional unit from grams to kilograms alters this ratio by 10 to the minus 3. The gravitational constant is then changed by the same amount. This agrees with the result obtained from equation 13.1. Those who are familiar with the first edition will have noticed that the values of the natural unit of inertial mass and related quantities, as given earlier in this chapter, are larger than the values given in the original publication. At the time of the original investigation, it seemed clear that a factor of 1 over 3 entered into the mass situation in some way, and there appeared to be sufficient justification for applying this factor to the size of the basic unit. As brought out in the preceding paragraphs, we now find that the 1 over 3 factor is a result of the one-dimensional nature of the as-if gravitational interaction. This factor has therefore been eliminated from the mass units. As a result, the natural unit of inertial mass, as defined in this edition, is 3 times the value given in the first edition, with a small adjustment to reflect the results of the continuing studies of the details of the phenomena involved. The use of these larger units has no effect on the physical relations involving inertial mass, as the expressions of these relations are balanced equations in which the mass terms are in equilibrium with the terms representing quantities derived from mass. And that is the end of the chapter. The next chapter, chapter 14, is called Cosmic Elements. But I will just conclude by saying, don't get discouraged if you didn't understand any of this. I didn't understand that much of it, and I've probably read this chapter 5 times. And, you know, this is something that you just read to figure how, get what you can get out of it. And obviously, if you want to really understand this, you're going to have to read it over and over and over and study all of the equations and figure out, go through all the algebra that he is putting on here. And, you're probably going to have some kind of table with you that's got all of these constants listed, and you have to be very familiar with all that stuff. It's not necessary to understand the reciprocal system. I think it's important just to give it color, just to give it a sense of this is what Larson is going through to get to his conclusions. His conclusions are not coming out of no place. This is where they're coming. So if you really want to check him, this is how you check him, by going over what he put down. Okay, we will start up with chapter 14 tomorrow. Thanks for tuning in. Have a great day.